Hello everyone. I'm going to share a presentation with you today, which actually will showcase various kind of architectural elements and various kind of architectural philosophies that as a student of architecture you can start looking at, which would help you in future to evolve yourself into a different kind of a person, different kind of architect. It's very easy to consider architecture as a mainstream field where you just have to make glass boxes and not worry about what's going to happen after that. But in reality, if you start looking into the each and every aspect of what a difference, like our professors used to say, a single line can make to the whole building, it really makes a huge amount of difference when you start deciding for various factors which are not visible in your lines. So there are multiple aspects of it, and that's what I'm going to showcase today. I'm going to share a presentation which actually describes Shift's philosophy and the way that we work it. So, Studio for Habitat Futures. This firm was formed by architect Sanjay Prakash, and he's been working in this field since last 30 years now. Earlier, this practice was mainly the sustainability was called as alternative architecture, which I don't know why that word came and how it came. While what we feel that the mainstream architecture has to be the way that alternative architecture was seen at one point of time. So I'm going to show you some basic principles and philosophies of how we work and what are the major aspects of shift. So there is an approach which is conformist approach, which means that in a mainstream architectural practice, when you design something, it has to conform to various aspects, bylaws, and make sure that the building is safe. So the first principle of conformist is to make a safe building. This example over here is a building in Pokhara. It was built in about 6 to 7 years. It took 6 to 7 years to build this building. Main reason being that the person who was building it was not from Nepal and he was a British national. It wasn't easy for a person coming from Britain to settle in an area which had a lot of local issues where, as you see today, Naxalites create. At that point of time, there were local issues where it was not easy for him to settle into a neighborhood situation. So what was decided was that instead of buying material from outside, we will start excavating it from our site, get local people to excavate that material, build our walls, try to harvest locally available wood, get local people to make that structure, and create a structure that would actually generate a lot of employment for locals. Initial days when it started, there was a lot of mara piti, you can say, that people were trying to say ki acha paisa zyada chahiye, I want more and this. But after some time, in about 6 months, the situation started changing. People started loving this person because he was the person who was actually training them. The locals were getting trained in this material. The locals were feeling pride in using their own material, which was stone and wood, which was locally available. And it actually, in a way, created a good harmonious situation for both. The picture on your right, what you see is of a truss, which was made up of wood and nails. And the most important aspect of safety, which was earlier safety for the user to be able to build here and live safely so that he doesn't get kidnapped somewhere or his family member doesn't get kidnapped. The later aspect of the safety is also that instead of using concrete and steel, we were able to build a building in a wood and local technology. And in the earthquake, which happened in Pokhara in 2015, the building was completely safe. And that is what gave us a confidence that yes, there are technologies which are local, there are materials which is not concrete and steel, but you can still build a building which is earthquake safe. So the message that we got from them when the earthquake came, because we really were worried what happened, how safe they are, was you see at the bottom of the screen. So what I want to say that it's not necessary to always use concrete and steel to create safe buildings. You can create safe buildings using various other materials. And they are available in abundance. They can create a social impact, they can create a local impact. On at the same time, you can make a building which is safe and also follows the bylaws. It also follows all the mandatory codes of structural design. Another example, this one was a meditation hall for Gnostic Center in Delhi. This one, the main reason to design this building was to create a building which is not very costly. And what you see on your left hand side is a truss, which is a bicycle truss, which uses not more than 2 inches of wood. If spread all over, if I melt all of this wood and spread it on a floor area, it will be not more than 2 inches. And the magic of this is that it uses very less material and still creates an impact, uses wood, not steel, not concrete, and uses some timber with nails, and you are able to create a structure which is 6 meters in diameter. So this structure what you see is about 6 meters in diameter. There is a funny chair which you see in the middle. This chair was created for the sadhaks so that when they meditate, they don't, if they get tired, they can actually rest back. So you can create safety by using various other materials. So in a mainstream constrained life of architect, where they feel that okay, to create a safe building which is earthquake proof and which is fire proof, which is proof by various other codes, it's not necessary that you have to use one material only. I'm going to another conformist approach, which is the code compliance. So another conformist, when you do a building, it has to be code compliant. This project was in Manesar, IT building, for more than 10,000 people in this building. Extremely high energy performance, extremely water conservation approach was taken. But what was really important was that when we designed this building, the code was not allowing us to use our FAR, which was balanced. The reason being that we were not able to provide parking for the project. When you try to make a building which is code compliant, you also have to provide parking for that amount of square foot that you are going to build. We decided to make a basement which is not 3 meters height, but about 4.5 or more. What we managed to do was that we created a multi-level car park in this basement, which allowed us to have as many cars as we want today. Why did a real estate company agree for it? It was not easy to convince them, but what was the most important aspect of this was that today we know that our society is based on cars, but the future of our society will not be a car-based economy. We are going to go away from cars. We are going to use a lot of public transport. What will happen to those basements in future?
Mayank, sorry to interject, but it seems that Bharati Vidyapeeth had lost connection.
Okay.
They just came in right now, so they were wondering if Spire Edge building can be
Yeah.
re-explained.
So this building, Spire Edge, this was an IT building. Can you hear us now? Just raise your hand. Can you hear me? Yeah. Okay. So this building was an IT building. This was designed for about 10,000 people. Extremely high energy efficient, high water conservative approach was taken. The game changer in this was that we were not able to use our FAR which was available. Reason being, to being a code compliant building, you have to provide for X number of cars to use your FAR. The problem that happened was that if we managed to create 3 basements, we were not able to house about 2,000 plus cars, which was not easy to do in a basement of this size. So we decided to not make a basement which was 3 meter high, but we decided to make a basement which was 4.5 meter high. This gave us an opportunity to create a multi-level car park. What will happen to this multi-level car park? Why did the client agree for it? See, today all of us know that the cars are not going to be the future of our society. We have to give away our cars. We have to get away from the petrol-based economy. More and more public transport will get into the place. What happens after that to these basements which have been created for car parks? The main reason that the client agreed for it, which was a real estate company, was that in a 4 meter and a 4.5 meter height, you can actually create a factory inside it. So a basement which is today used as a multi-level car park, in future can be used by robots as a factory where you can produce your goods. And this is a long-term initiative. So this is what a client also sees in whatever you try to propose in a project. Another example, triple ITD. This was an interesting project because this was a competition project that we won. Uh, Most of the IT-based buildings today and the colleges are air conditioned. I'm going to showcase you what value for money we tried to add to this project. You see the sandstone facade, which is actually the local sandstone which is available. We created a very high energy efficient building, which means that after this sandstone, there is a thick insulation behind it. And after that, there is a wall. So this is not a 200 thick wall, 230 thick wall. This is about 450 thick wall. And this is not a complete glass building. This is a building which is completely shaded from various angles. What did it help us to do was we were able to reduce our air conditioning demands for the main building, the academic building that you see. What we proposed to the client after this was that in order to use your air conditioning in the morning time when your academic buildings are used, we convinced the clients that the same air conditioning which is used in the morning for your academic area can be provided to all your hostels in the day, in the night time. So all of this was done without increasing their cost because we created a building which was energy efficient, which doesn't consume too much of energy, which means the air conditioning demands are not very high, which also means that you're not going to buy two machines to provide air conditioning. You're just buying one machine. In the daytime, the air conditioning goes to the office or the academic areas, while at the night time, the same air conditioning can be given to the hostel students. And it doesn't cost more than a pizza per month for them. So the operational cost is very low for this guy. So this is a district chilling with concept which was used for the first time in India. And till date, the students of this college really appreciate this effort because in the monsoon months or in the summers, it is a great thing for them to have a, which is a air conditioned hostel without paying too much for it. Another value for money, how can we add to it? This was a farmhouse we created for a retired couple. They had a very tight budget of not more than 1 crore for the whole project. The built up area, if you start calculating, this would cost you more than, I mean, if I start calculating in the mainstream approach, this would have costed us like anything. It would have costed you not less than 3 crore. We decided to not use RCC. We decided not to use concrete at all. This helped us to actually reduce the project cost dramatically because there was no steel used, there was no concrete used. And in lieu of that, you actually get an amazing brick vaulted ceiling, which is completely brick vaults, and you don't use concrete at all. It actually creates an impact, it creates a story for the client, for themselves. It creates a volume which everyone can enjoy. It allows a lot of local employment because you're using brick and not an industrial material. And you can create a space which is not costly. And this, what we see, is a conformist approach, which means that all the buildings that you design have to be safe, have to be code compliant, have to be profitable to the clients, at least at the capital cost. All of this is mainstream. And still, you don't have to invest too much on it. So you can create something which is mainstream, safe, code compliant, profitable, all of it, and conforming to your laws and not compromise on the quality. Instead, create something which is a magic. The next approach is a green approach, which means that if you design a green building, you have to be sure that the building is efficient. This project that you see is an energy Terry. This is for Terry. This was India's first off-grid project built in 2001. It was actually the first project in India which was net zero energy, which was not connected to grid at all. And it is an air-conditioned building. This was done actually by reducing the air conditioning demands by using a lot of insulation in the material, orienting your building properly. But what you see, the most important energy efficient aspect is these chimneys. Can you see the pointer? These chimneys over here, These are actually earth air tunnels, which mean that 4 meter below the ground there is a pipe running, which actually takes the air from outside. Your air travels underground for about 20 to 30 meters, and the same air is provided in your rooms. The magic is that 4 meters below ground, there is no temperature variation, which means at any point of time you will get 24 degrees Celsius as that constant temperature when you dig 4 meters below ground. So all the air conditioning was actually done through earth air tunnels. This is called earth air tunnel, and you actually get a lot of fresh air instead of basic conditioned building where you actually keep circulating your air again and again. You live in an air conditioned building. If you live in an air conditioned building, you don't have your fresh air inside, because what you try to do is minimize using your fresh air. It increases your cost. But over here, it actually decreases the cost because you're not using any of your air conditioning system like chillers and all. Instead, you're using earth to provide that cool. On the extreme left that you see is a solar panel, a skylight with a solar panel on it. And this is how efficiency can be achieved. This is another example of efficiency. One more example for efficiency. This was a project for Taj Safaris. This is a resort. Uh, the important aspect was that when you're building something very close to river, you cannot build it in a material which is permanent, which means that you have to create something which is temporary. A good example of a temporary building is to actually create a tent, which means it's a temporary structure. What we did over here was the whole building was lifted above ground, which allowed the water flowing very close to the river actually flow. So this picture that you see, the water actually can flow below the tents, all your buildings. So there is no water stream which gets cut. The problem with tents is that when you start using tents, and if you are designing for a high-end luxury resort, you cannot make a non-air conditioned building. You have to create an air conditioned building. So what we did was we created a model where if you see the section on your right hand side, that there were two tents used. The first tent was the upper layer and the second tent was the second layer. The two tents, what they do is we actually do misting. Misting is something where you send your water molecules to a very small particle level. So you actually mist the whole area and create a coolth in this area. What it helped was it reduced the air conditioning demand dramatically. So instead of using 15-ton air conditioning, the whole tent was designed for 3 tons. Why is it important for architect to think about it? Uh, do we really have to look out after the air conditioning demands and all of it? Yes, we have to, because if we start designing building which consumes too much of energy, your clients will start hating you. You are actually creating a building which is inefficient, which means that today there are buyers in market, tomorrow there will be no one who will use this project. If you don't create a building which is thermally comfortable, your visitors and your guests will start complaining about it. So this is another example of efficiency. You have to create a approach where you can actually substitute a lot of material, which means by substituting means that instead of using brick, which is fire brick, or a clay bricks, which is fire burnt, you can actually use laterite or you can use soil stabilized earth block. This example that you see is of TZ Bangalore, where the complete housing was done using laterite and stabilized earth blocks. The slab that you see, it was actually created using railway sleepers. So this is a filler slab. The railway wooden sleepers which were available earlier, which was thrown away, and we got it at that price, at the thrown away prices, because it was a material which was waste for the Indian railways. We actually used it to create a slab where you actually reduce your demand for concrete. So this part that you see in the middle is actually the concrete slab where very less concrete is used. So you have to create an opportunity where you can substitute a lot of material. The photograph of a landscape that you see on the top is a landscape which uses no cement, which means you can actually only use stones, interlock them, and create an opportunity for water to keep percolating. This opponent heater that you see in a situation like Bangalore, after a heavy rain, you can continue to use it because everything is porous. So all that water falls on it actually starts percolating below, and you actually create a place where it's green and it's also friendly. So this is what you do when you create a green building, that you create a building project which is efficient. It reduces your operational cost, which is what you look at. It creates substitution for your resources. Substitution can be at various levels. It can be substitution of your material. It can be substitution of your energy use. So you can create these aspects while you're designing for the project. So there is a mainstream approach, there is a green approach. There is a sustainable approach to the whole aspect. This building, Mirambika, this is a school in Delhi, which has no classrooms, which means that you don't have to create classrooms to teach students. This is a progressive school which, which actually questioned the belief of client. This was a ask. This school was run by Ashram, and what we did in our design share it is a design discussion that we do with clients. We started questioning that what is their requirement, and we realized that you don't need classrooms to teach students in the school. You need various kind of veranda spaces which can be adapted to their requirements. So this school actually has no classroom. I think it has one classroom because there is a mandatory norm to have a classroom to get it passed to government body. Otherwise, all you see is various kind of veranda structures made in concrete and slate, and it's very airy. You don't need tube lights. You don't use lights in the any time of the day. You don't have to use light. Only enough. What is enough is to use fan, and that's more than enough to use. And that's how a sufficiency can be approached. Another way of sufficiency. This was a resort for a high-end luxury resort in Sri Lanka for 6 senses, where we discussed and discovered with clients that the people who are going to use it will need air conditioned rooms. So how can we actually create a sufficiency kind of approach by not providing too much of air conditioning? We decided to create a glass box that you see in the middle. This glass box is a 10 feet by 10 feet bedroom which is air conditioned, and that is the only space which is air conditioned, which means that if you have to sleep at night, you get inside this room and you sleep. Otherwise, throughout the day you can use the space around it, around your room, and you don't have to air condition all of it. uh, Another thing that was done, because this was in a very mangrove based island where there were lots of mangroves, we decided to use locally available wood and raise the whole thing so that the guest can get a great experience and we don't harm the mangroves around it. So the ecology doesn't get harmed. Resilience. Uh, the example of resilience in this project that you see, this is a IT building for Agile Technologies. Can you hear me? Bhati, will you
Yes,
be?
I can.
Uh, so, for Agile technology, the resilience was created by actually allowing a lot of rainwater to be stored, as much as 50 lakh liters. So no rainwater that falls on this site actually goes out of this site. The resilience was created by actually allowing them to grow their own food on site. And that's how resilience can be created. Another example of resilience, a project in Sundarbans that we are working on presently. We decided to not change the local situation. This is very close. Sundarbans uh, area has a lot of mangrove. Again, the same situation. A lot of mangrove plantation around it. If you build anything very close to mangrove, you can destroy it, which means that even if you use concrete, it can start destroying the mangroves. So you have to use technologies or techniques that will not harm mangroves, which means don't use any cement on site. So we decided to use construction technology. The interesting diagram that you see And this is where we sit, the construction technology, the local material. One change over here can actually change everything in the whole ecological system. And that's the kind of difference as an architect you can make. If I start putting concrete and steel and alien materials in this whole scenario, you will realize that the mangroves will start vanishing. Mangroves will start vanishing. You will see the aquaculture will start vanishing. Slowly, the whole site will change its own character. So the reason why we have chosen this site will suddenly wipe off. So that's how a material difference can be made. And the resilience, you have to make sure that the resilience is created, that all systems work hand in hand. This one is another example that when you're designing something, you can actually give them an experience of having all of this on site. So if you go to a resort and if you tell your clients, okay, let's go, I'm going to take you for fishing, they would love it. And that's the kind of experience that you will create for them. Equitable. The Bamboo Research and Training Center, this is the project that the pictures of which I was showing you about some time ago. This building is what is already built, and all of it is getting built in locally available bamboo and mud. What it does is, instead of using industrial material, which actually in which most of the money goes to the industry which creates cement or which creates steel, you use material which is very labor intensive. Using labor intensive material makes sure that you actually generate a lot of local employment. The moment you start creating local employment, you actually are able to create a whole magic because the whole ecosystem starts changing. This project was a bamboo research and training institute, and we decided what best material can we use if bamboo is not being utilized, and that's how the bamboo was used. So the whole building is built in bamboo, getting built in bamboo and rammed earth, and it is a structural bamboo, and it is equitable in a way. It creates lots of local employment, gives an opportunity for others to actually learn from it. Another equitable project. This is the IT building, which was a competition project again, which was for a Ministry of Gabon. This country, Gabon in Africa, which is in Western Africa, has no construction skills. The population is not more than 10 million. The problem here is that everything has to be assembled outside, which means whatever material you will use will come pre-engineered, pre-assembled from outside. How can you create equity based society in this kind of situation? We decided to use steel, which is actually getting built somewhere in Europe, and all of it will get assembled. We will use glass, which doesn't get manufactured in that country. Again, it will be imported from somewhere outside. But the facade that you see, which is of brown color, is actually wooden shingles, which means that you actually get local people to create wooden shingles for you. You set up that factory over there, you allow them to use wood, which is their local material, and allow it to create a statement for themselves. So even if it's a challenging situation where there is no construction technology available, you can still create an opportunity for local equitable based solution. Another example for identity providing. This is what is the most important aspect for an architect. How do you create identity? This is a funny example for a school in Gurgaon where actually the kids remember the classrooms by the shape of animals that they see on their flooring. So the kids remember that, okay, you have to go to the elephant classroom, and that's how they run towards the elephant classroom. Or this door that you see in the middle, this door is very close to the main door, which is the big door. But this smaller door is used only by the kids, which means that they have a sense of identity for themselves. It is a funny situation when you see that the kids say, okay, I'm going out, and they use this small door to get out of the classroom while the teachers are sitting inside watching them. Oh, I can't use it. And that's the main fun part of it. And that's how they create identity for the kids for the school. The walls that you see, all of it actually gets painted by kids, and a photograph is taken at the end of the year. It's given to all the parents of the school, and then it's whitewashed for the next year to actually start painting it again. Another example for identity providing, this project for Taj Safaris, very close to Panna, where the local technology was to use sandstone shingles. We realized that when we went there, we were not able to get any sandstone shingles, which meant that people have stopped using that technology. So instead of using something else, we decided to use local technology, which was stone-based construction and sandstone shingles. What it inspired was the local neighborhood people actually started to come to our site and started asking us, do they need their shingles? What we did was, in lieu of getting their old shingles, we told them, why don't you buy the old new shingles and give us the older ones, which actually gives you a good look and feel also. So instead of giving them money, which means that okay, they will now put a concrete roof or a steel roof, we told them that we'll give you a new stone roof that you can use, while give us your earlier used stone, which is rough and very raw in finish, which today of course we can't buy it very easily, otherwise we have to pay a lot, and give them this opportunity to actually have a pride in it. Now the locals actually say that the project which they have actually built by themselves now uses the stone which was used in their houses, and they feel pride in this whole thing. It gives them the identity for themselves, and that's how a sustainable society can be created. So it's not only by creation of a building you are just making a smaller difference, you are making a larger difference to a larger society that you look at. And the last aspect that we look at is the holistic approach to the whole problem or the whole situation, where you create a harmonious project. This building, this is a expo building which was created in a record time of 9 months. This building was created for an expo, and it was designed only for lifespan of 6 months. So we decided not to use. This was when Mr. Sanjay Prakash started his practice in early 90s. It was decided not to use brick, not to use cement, instead use stabilized earth blocks, which means that you can actually get all of this soil excavated from the ground and use the same soil. Some soil was imported from outside, and create a stabilized earth block based building which can be washed off after 6 months the expo is over. This building is standing till date. There is a lot of effort, there is a lot of hue and cry by art lovers, because this was actually a art expo building, that they don't want to break this building away. The life of this building was designed for 6 months. It was then certified for 3 years. It was then after that certified for another 3 years. And it could have been, if the initial brief was different, it could have been built for 100 years of lifespan. But because the brief was to build it for only 6 months, it actually stayed for more than 30 years. And today, when we are going to wash it off, this is what we are going to do. All that you will get is few pipes left over, which can be sold in the market, and few sandstone slabs, which can again be sold in the market. And that's how a holistic approach can be taken to the whole thing. Uh, Another example, an aspirational project which was world's largest bamboo dome in Shanghai in China. This brief that we got for the World Expo was future cities, which means that we need to design something where the future cities is going to portray, can be portrayed through our examples. The easiest and the best material that we felt to use was bamboo. The challenging aspect was that the China, unlike India, doesn't have a bamboo code, which means that if you have to make any building in bamboo, it's not doable in China, but it is doable in India, and that's the most important part. So we created a project which was in bamboo. We went there, we got it proof checked by their Chinese engineers in their Chinese codes for other kind of buildings, for a wood building, for other building. And it aspired China to actually introduce a bamboo code. And after this, China now has a bamboo code for themselves. And that's how a difference and aspiration can be created. Another aspirational thing was, this was the first time when India had seen a green wall, which means a herbs based wall that you see on the roof of this dome. This all of this are the green herbs which belong to India and China, and in a ways show a coherence and a society which can be which can live hand in hand in a way. So this project actually created aspiration for a lot of people to actually start using bamboo in China and in India, and actually promoted it as a material. Another approach, it has to be collective. This is a very interesting example. This was for, again, for a NGO called Lok Chumbesh. The as the main brief was that there were various villages in Rajasthan and they had no schools, and they had no school buildings also. So the brief was to create 300 school buildings all over in Rajasthan, various places, various villages in Rajasthan, and there were only 9 architects involved in this project. How can you create 300 buildings? It's almost impossible to actually deliver 300 buildings in a span of 3 years. That too in a place where no contractor or will has a will to go, which means you have to use your local resources. So what was done in this project was, there was no architectural drawing which was made. There was no BOQ which was made. There was no structural drawing which was made. It was a collective effort, a collaborative effort to actually teach local people of how to construct their own school. And that's how they did. The photographs that you see on the top is a collective effort where architects are explaining them of how a building can be built, what all are the important aspects of a building, why a foundation is important, why a roof is important. The photograph in the middle that you see is of a local person who is trying to create a model out of thermocol by themselves to actually decide, okay, this is the school building and this is where we want. And the lowermost picture that you see is actually the local techniques that they have, and they created their own school using those local techniques. This actually got a lot of old masons back to Rajasthan to start teaching it to the next generation so that they can learn how to use stone construction. And that's where the collective effort can be seen. So it's also enabling of the technology which actually can create a lot of difference. Another example, a living example you can say in a way, this is for IIT Jodhpur campus. It actually has a lot of various aspects of energy, water, various layers, various networks which actually work hand in hand, which I will show you next slide. This slide that you see over here. So there is an energy network which works all around. In the center, you see the main users of this project, which are the students, the local people. On your right hand side, you see the air conditioning systems. On the bottommost part, you see the water systems. On the topmost part, you see various plumbing systems. And that's how a network can be created. And this is what a difference can be made. This network actually can sense that which rainwater tank has enough water, and it can actually take that rainwater from that tank. It is like a battery bank which can be used two-way. You have to create a network which actually talks to each other. So it's not only one technology which works, it's all of it which can work hand in hand. And this, as an architect, we are responsible to create it, which means that if you're creating a rainwater harvesting tank, which can provide water, can be used in seasons when you don't have water for your water requirement. The same water, do you want to throw away or you want to use it somewhere, you can use that water to be provided for air conditioning after treating it once, which means that after you flush your water, you can treat it, you can send it to air conditioning. The same water can be used for irrigation, and that's how this system is in a closed loop system, and that's how a metabolism can work, which means that you have to look for each and every decision that we take in a closed loop manner. If I am using stone, what will happen when the building gets over by its lifetime? What is the use of this material? Does it has any recyclable value? What is the material that I am using? Does it have embodied energy? How much embodied energy is it having? Can it be recycled? Can it be reused somewhere else? These are the calls or decisions as an architect we can make, and it creates a huge impact on the society in on a whole through. And that's where the whole next frontier comes, where you actually create an aspirational value, you create a harmonious situation where each and every project is a living project. It doesn't matter where it is, what size it is, and it can create a difference to the whole society. You know. And when I have shown you all of these projects, each one of them are living, and I can say because all of them, I think more than 50% of them are created in front of me, and they have still today are giving back us our what you say, the efforts that we have put in, it is coming back to us in a way. So all of it has to go through different lenses, but at the end of the day has to be a living project or living building in a way. This ends the presentation here.